In this unit, we're going to be looking at pointers, which are very valuable as we start to expand the way we can use data. There are two ways of accessing variables. Everything we've done to this point has been using direct reference. The other method is called indirect reference, and this is where pointers come in. But before we do that, let's take a look at what we already know. So talking about direct reference. So what we have here, a variable is declared. We know how to do that. So here we've declared a variable called value that is of type integer. And we know that we can access it and we can do things like assign values by using that name. So we could say, we could print value, we could get the user to enter it, and we know that what happens when we execute this line of code is that somewhere in memory we're having enough space reserved to hold an integer value, that its name is value, and that the value 12 is written into that space in memory. With indirect reference, we're going to now declare a variable, but we're going to, instead of accessing it directly like we did up here, we're going to access it using another variable called a pointer. So the declaration that I have here is declaring a pointer. And the way we know that is because of this star here. So we have the name of our pointer, value pointer. The star indicates that it's a pointer to an integer. So what happens when we declare this statement right here is somewhere in memory, we get enough memory reserved to hold an address. So that's where the indirect part comes. So now we're talking addresses instead of values. So there's an address stored in here that points to any integer value. In this case, it's pointing to value. So remember we had value stored in some memory location, maybe it's memory location X. So now the address that's stored in value pointer is going to be wherever in memory that is. So it's going to be X. And using that address, we can now get at the contents of this other variable. So that is called indirect referencing. So as with any other variable that we're using in our program, we have to declare a pointer before we can use it. And as I said on the last slide, a pointer is simply a variable that contains an address instead of data. So how do we declare it? We say what kind of data it's going to point at. We use the indirection operator, which is the star, and then we provide the name. So when that happens, value pointer gets some space reserved in memory. It's designed to hold an address. If we do our declaration as we have here, it doesn't have an address assigned there yet, but it's big enough to hold an address. And eventually, we can use that to point at another variable as long as that other variable is an integer. So after we declare a variable, in this case a pointer, the next thing to do is to initialize it. And we can initialize it to three things. First is 0, and that's not the best choice, but it is possible. We can initialize it to null, which is equivalent to 0, which says I'm not pointing to anything yet. Or I can assign it an address. When do we do that? We can do it in one of two places. We can do it at declaration time. So we can see here, there's our declaration for our pointer, and there's our initialization to null. Or we can do it right in an assignment statement. There's our pointer, it's already declared, and here is our assignment saying we want the address of value to be assigned to our pointer. Now if we decide not to initialize our pointer, we can at any other point in the program assign a value to it. And to do that, we're going to use the address of operator that we've been using with scanf function for a long time. So this is nothing new to us. So let's look at what we've got here. We've declared a variable called value of type integer, and it is assigned the value 12. So over here, somewhere in memory, and I've said in this case at address 8050, we have it reserved enough space to hold an integer, and we have called it value. Right now, it has 12 stored in it. The next line says, I want you to reserve enough space for a pointer to an integer now. So this is going to be enough space to hold an address, and we're going to call it value pointer. So here we've reserved enough space for an address. That value actually isn't in there yet. So we have a blank space. We haven't initialized it to anything, but we've reserved that space. We're calling it value pointer, and right now it doesn't have anything in it. When we get to this next instruction, we're saying assign value pointer the address of the variable called value. So the address of value is 8050. So now we're going to have that 8050 stored in value pointer. So we have the address of operator that we use to assign the address of any variable to our pointer. So we have two operators here, our indirection operator and our address operator. Now when you start working with pointers, you're going to hear the term dereferencing. And all that dereferencing means is to be able to get the value that the pointer is pointing to. So it's like you point your finger, you follow the line of sight, you can see what you're pointing at. Dereferencing allows us to take our pointer, which has an address in it, go to that address, and extract the value from there. So that's what dereferencing is. Get the value to which the pointer points. And in order to do that, we're going to use that indirection operator again. But here, we sometimes call it the dereferencing operator. They're exactly the same thing, so it's the star. So with pointers, you're going to use the address of operator, and you're going to use the indirection operator, which is the star. So here, what we're doing is we're printing an integer value, and we're saying get the contents of where value pointer is pointing. So this is my dereferencing or indirection operator. It says, and the easiest way to remember it is, give me the contents of. So this particular line, printf %d star value pointer, going to go to value pointer, read the 8050, go to address 8050, read the 12, and print that. So let's take a look at some sample code here. I've got two very simple declarations. The first, I'm declaring a number and I'm initializing it to the value 25. Now I'm declaring a pointer to an integer, and we can tell that because of this indirection operator here, the star. I've called that pointer number pointer. It's not unusual for pointers to have the word or the letters PTR in them. That way when you look at the code, you know that that's a pointer. Notice here that I've initialized it to null. So right now, my pointer is not pointing to anything. If I look at my first print statement, I'm printing number is equal to, and I'm printing number, so it should print number equals 25. And then I'm printing number pointer equals. And notice here I have %p. That p stands for pointer, and what it's going to do is allow us to print an address. So that value is going to get printed in hexadecimal as an address. So here I'm printing number pointer. If we look at the output from that, we can see there's the number equals 25, and number pointer equals 0. Why does it equal 0? Because I set it to null when I initialized it. Now let's see what happens. So here we're saying assign number pointer the address of number. So the address of number is wherever number has been stored in memory. If we look at the output, and we're going to use the same thing here, So number equals number pointer, or sorry, number equals 25 still. Number pointer is the address stored in our variable number pointer, and the contents of number pointer should be our 25 again. So we're printing number, the pointer, and the contents of the pointer. If we look at that one, so we'll mark this one as green. So here we print number equals 25. My pointer has now been assigned to wherever number was in memory. So we know number went in at address 45FEB0 in this particular running of this program. But more importantly, the contents of number pointer is our 25. Now, let's look at the next section. And we'll mark this one in blue so we can differentiate the three. So here I have said the contents of number pointer is now assigned the value 100. So where's number pointer pointing? It's pointing to number. So this instruction down here is going to change number. It doesn't change the pointer itself. It changes what the pointer is pointing to. So when I print my output now, I print number, I print the pointer, and I print the contents of the pointer. So number is now 100. The pointer is still pointing to the same thing, which is where number is stored. And here I can see the contents of what I'm pointing to is 100. So with this slide, you can see the evolution of just the number and it being null, to the number, looking at the address where number is, and then the contents of that address, which is equivalent to the contents of number. And then finally, we changed it using indirection, and then we can print it, we can print its address, and we can print the contents of the pointer. So what we can see here is our direct addressing here, and our indirect here. So let's review these concepts. First of all, a pointer is simply an address. It's something that we can use to reference or get at the contents of another variable. We have the ability to declare them. We need to specify the data type. I'm missing a star here. There should be a star there. And then the name that we give to the pointer. So here we've got a character pointer that's pointing to a character. The initialization or assignment, we're going to use the address of operator. So our pointer name is assigned null. So here, for the pointer we've declared up here, we're assigning it null. It's not pointing to anything yet. Or we can assign it the address of a variable. So here we can say the address of CH, and that's assuming somewhere we have a variable declaration that looks like this. So the address of CH, and that's assigned to CH pointer. Then finally we have our dereferencing, so that's our star or our asterisk. Here we're saying the contents of the pointer name is assigned a value. So here the contents of where we're pointing is now going to have a capital N. So remember, we have our two operators, our address of operator, our indirection or dereferencing operator. This one we use to set pointers, this one we use to declare and to get at the contents of where it's pointing.